Hey there, Mike Flannery with Red Hat here, and today I'm going to give you a 2-for-1 demo special. We're going to be demoing the features of Gluster, and I'm going to be executing that demo out of our Ansible automation. If you'd like to know more about how I created this demo and how I created the playbooks, and to see the actual playbooks that I created, please head over to linux-nerd.tech and search for the Gluster Demo blog. All right, let's get started. First thing I want to show you is the systems that I'm going to be using to create this demo. I have 3 servers, Gluster 1, Gluster 2, and Gluster 3. We're going to execute the playbook gluster-demo.yaml by executing Ansible-playbook and then the YAML file that we want to execute. In our playbook, the first thing we're going to do is install the Gluster RPMs, doing a yum install glusterfs server on all of our servers. We can see what was installed by doing an rpm-q, and we can see the version that we've installed there. We can also verify that this is on all of our servers by doing Ansible ad hoc. We do an Ansible all-a, and then the command that we want to execute. And that'll execute then on all of our servers, and we can see with this that we've installed the same version of Gluster on all of our servers, which is generally a good thing. Now that we have Gluster installed, we're going to configure our firewall. First we verify the firewall is running, and then we open ports for SSH, GlusterFS, NFS, and Samba. So we'll verify that with the firewall command list all, and we can see SSH, GlusterFS, NFS, and Samba are indeed open now. Now that we've got our firewall configured appropriately, we need to start the Gluster daemons. We're going to start that Gluster daemon on all nodes using a systemctl start glusterd, and we can verify that with a systemctl status glusterd. Now that we've got Gluster running on all the servers, we can create our trusted storage pool. And this is what allows all of the Gluster servers to work together as a single cohesive unit. We do that with a Gluster peer probe command, and we can verify it with a Gluster pool list command. We're running this on the local host, which is Gluster 1. And we've also got Gluster 2 and Gluster 3, and we can see that all 3 are connected to our trusted storage pool. So now they're working together, but we have no volumes created yet. In order to create a volume, the first thing we need to do is create some bricks. And the first thing we need to do to create bricks is to create physical volumes on our physical drives, create volume groups out of our physical volumes, and then create logical volumes out of our volume groups. Can verify that with a pvs vgs lvs command. Here we can see our physical volumes, we can see our volume groups, and we can see our logical volumes. And we've created 2 different objects in our logical volumes. First is a thin pool, and then we create our actual logical volume out of the thin pool. We do that for a couple of reasons. Number 1, it provides a lot of flexibility for us, and number 2, it allows us to create snapshots and clones. Now that we've properly created our logical volumes, we can format them and mount them and then create our brickders. We format it with the XFS file system. We then mount it, and then we create a directory inside of that mount, and that's called our brickder. We can see all of that by doing the mount command and then doing a tree on RHGS. /RHGS is our top level directory. We then have our mount point SDB, SDC, and SDD. And then we have our brickders, SDB, SDC, and SDD underneath those mount points. We create the brickders there in case this mount should disappear. If this mount disappeared for some reason, our brickder would disappear, and Gluster would be notified then that something's wrong and would stop writing data into that brick. If we didn't have the brickder here and instead had Gluster writing directly into the mount, when this mount disappears, this turns from a mount point into a directory. And Gluster would see it and would continue writing into the directory and would eventually fill up your local file system, which would be a bad thing. So always create your brickders and underneath your mount points so that that can't happen. All right, now that we've got our bricks created, we need to create our volume. We're going to create a 3x replicated volume, which means that when we write a file into this Gluster volume, it's going to be written to all 3 nodes in the cluster simultaneously. So we do a Gluster vol create command to create our volume. We then set some variables to allow for snapshots. We update our smb.conf file with the information for our volume, and then we're able to access our volume. We can see the volume with a Gluster vol list command. You can see we get a whole lot of information out of that command. We can actually get more info by doing a Gluster vol info, where we can see the volume name, how many snapshots are on it, how it's architected. We can see the bricks that comprise that volume, and we can also see the features or the options that have been set on that volume. We can do one other command here, a Gluster vol status, where we can see all of the processes that are running for this volume. One of the most important parts here is the online yes or no. When all of them are online, then everything's running just fine. So now that we have a healthy volume, we can mount it. And we do that with the mount command, and we can verify that also with the mount command. So we can see that on /gluster/vol1, we have mounted the vol1 volume from gluster1. That's of type fuse glusterfs, which is it's a Gluster mount type or Gluster file system type that allows us to get some more parallelism and potentially some more performance off of our system. We can see that we created that as a 10 gig volume. We can also see that volume in Windows by doing an add network location. We then put in our location, Gluster-vol1. And then when we open it up, we can see our empty Gluster volume. Now that we've got a volume, let's put some data in it. We're going to copy some image files into the volume. We can verify that with an ls command. And we can see all of our image files here. We can go to Windows and go back into our volume, and we can see the image files out here as well in the Pictures directory. There's all of our image files here. So let's pretend that our 10 gig volume is no longer big enough and we need to make it bigger. So to do that, we do a Gluster vol add brick command. We're going to add some drives or some bricks to our Gluster volume and double its size. So we add those bricks. We're then going to update our samba smb.conf file, and then we can verify that yes, indeed, our volume has doubled in size. Now that we've doubled it in size and we've got a proper size for our volume, let's create a snapshot of the images as we had them in there. We can see our snapshot name here, and if I come here and I can see my snap name using a Gluster snapshot list vol1 command. I can also see my active file system, and I can see my snapshot, and in this case, since we haven't done anything to the data since we took the snapshot, they're identical. So let's remove some of the files from our active file system and see the difference. Now that we've deleted all the November files, we can see the active file system here doesn't have those, but our snapshotted file system still has those, so we could still restore those files for the end users if we needed to. Now we can also enable self-service snapshots for our end users, which means that the end users themselves can restore the files if they wanted to on their own. And here we can see that that is a .snaps directory, so it's a hidden directory inside of our volume, but we can see that we've got all of the November data that was deleted previously in there. We can also see this data in our Windows system by mounting or adding a new network location. And we're going to add the snapshot, the dot snaps, and then the snapshot name. And there's our pictures directory and all of our data within. Now remember that our active file system has only the non-November files. We can restore our November files by doing a right click on the directory and saying restore to a previous version. I want to restore my pictures. We're going to restore them. Click OK, double click into pictures, and now my active file system has the November files or the November images in it again. Another thing that we can do with snapshots is we can convert them into writable clones. So that's what we're doing here. When we start the clone and then mount the clone, it's just like any other volume on our system. And we're able to do a tree or ls to be able to see the active file system for the clone now. Notice that we named it vol1 clone. We can see that we've got all of our files in there. If we go into Windows, we can mount that volume or that clone out here as well by doing an add network location, putting in the location, when it opens up, we'll have our pictures directory and then all of our images inside of it. And there's all of our pictures right there. And that's the end of the Gluster demo. Now I've got another playbook out here that I've created. Once we're done with the demo, we needed to be able to reset that demo. So I created a reset demo as well. This will unmount all the client volumes. It stops the Gluster volume, deletes the Gluster volume snapshots, deletes the Gluster volume clone, and then deletes the volume itself. Once that's done, we delete the PVs, the VGs, the LVs, we destroy the trusted pool, and then we're done. So again, if you'd like to know more about how this works, please go to linuxnerd.tech, and thank you very much for watching. Have a great day.